Hi, AP Calculus students. Welcome to section 7.1C. Just looking for my markers here. There we go. How are you doing today? Let's see. So 7.1C, we are going to be looking at functions where we have to find the intersection points ourselves and the upper and the lower function change. But most importantly, and you'll see one of these on the AP exam, what happens when the expression is x is written in terms of y, okay? And so here, this graph was given to us in the book, and here we're gonna make our own. Okay, so expressions or graphs in terms of y may be the only choice or the easiest, and here's what I mean. Notice if I asked you to find this area, as you go left to right, the upper function changes, right here at 0. Here's another problem. Look to the right of 0, right? Upper function minus lower function is the same function. It's a horizontal parabola. What are we going to do? So this means that we need to, but we should still be able to find this area, right? So what we're going to be doing then is when it's in terms of y, right, we are going to be doing the right-hand function minus the left. Upper values minus lower values, only it will be right minus left, okay? Instead of with x's, upper minus lower, right, vertically. So I found, you probably do this a lot easier than me. I kind of have a tough time when I've been given a y to find the x, like to graph it. So I do it in 2 steps. I first make my list of possible y's, and then I make a chart of the x's that go with it, and then I graph those xy points. So all examples here ask you to sketch a region and to find the area. And I just forgot something. I'll be right back. I'm right here, I promise you. Okay, here I am, I'm back. Okay, so example 17b, the graph was given. Notice we have the horizontal parabola x equals 4 minus y squared. That is right here, right? Notice that it is horizontal and opening to the left. And this is the line x equals y minus 2, right? So notice that these graphs actually intersect at, right, this y and this y here, right? And they gave us, they showed these points really clearly here. And this is the point -5, 3. Sorry, -5, -3. Let's just check it real quick. Is that true? Does that work? When you put in a -3 for y here, that is 9, 4 minus 9, yep, -5. When you put in a -3 here, -3 minus 2 is a -5. They do, in fact, intersect at that point, right? And so, so if I'm going to integrate in terms of y, then that means my lower and upper boundaries or values have to be y's, not x's, right? So here's the picture we have. So our integration is going to be, let's see, as I go, my lower y is a -3, right? And my upper y is a 2. My right-hand function is the parabola minus my left-hand function. I'm going to subtract that whole function. Yes? Okay, let's go ahead and clear that up a little bit. -3 to 2, 4 minus y squared minus y plus 2. So if it's okay with you, just to save some room then, -y squared minus y, 4 plus 2, I'm just going to put a +6 on that and save us a little bit of room here. There we go. Let's go ahead and, let's go ahead and integrate. That would be -y cubed over 3 minus y squared over 2 plus 6y. And that's from -3 to 2. So f of b, we're going to have to watch our details here. Like I'm one to talk, right? There you go. When I put in a 2, that's a -8/3. When I put in a 2 here, that's -2 and plus 12. F of b minus f of a. When I put in a -3 here, that is a -27 divided by 3. That's -9. Now it's a +9. This is -9/2. and this is minus 18. As always, I'm going to distribute my negative. There you go. I'm going to open up some space here and I'll erase it after. And I gather my like terms. Let's see. I have negative 2 plus 12 is a 10, minus 9, I have a 1, plus 18, I have a 19. So I have 19 minus 8/3 plus 9/2 is what I see going on here. Right, and so I'm gonna, what a pain in the butt. I'm gonna get a common denominator of 6. So let's do that right to left, right? So 6, that would be times 3, that would be 27. 6, that would be times 2, and then times 6. Let's see, if it were 20 times 6, 20 times 6 would be, it's late in the day, 120. Woo! Minus 6 is 114. There we go. So 114 minus 16 is a 98. I'm sorry, my phone keeps dinging and it's distracting me. There we go. Is a 98 plus 27. Gosh, I wish I felt I could use a calculator. So that's 125/6 is that area. Let me make sure I'm right. Okay, and let me turn off my phone. It is. And of course it's positive, right? Because we did right minus left, upper values minus lower values. Hi, it's me again. Okay. All right. Let's make myself some room. I'm going to erase this too, because in case I didn't give myself enough room in the middle, like I can come back this way a little bit. Okay, so what happens now when you have been given f of y equals y times 2 minus y? So if you put in a y here, it produces an x. Same here. That's what this g of y means. These are x's now. When you put in a y, right, and you take the opposite of it, it produces an x, okay? First of all, I am not good at graphing in terms of y, and I have no idea what y's these intersect at. Like what y's am I talking about? What am I looking at? So let's go ahead and set these two expressions equal to each other and find the y's that I'm talking about, a lower y and an upper y. So I'm going to call this 2y minus y squared, okay? So I'm going to do that right here since I gave myself room. 2y minus y squared. And I want to know where this expression equals negative y. So if it's okay with you, I'm just going to bring everything to the right. So I'm going to add a y squared to both sides. And I'm going to subtract a 2y. So I have minus 3y. All right. So that would be when I factor y times y minus 3. There we go. So I am going from a y of 0 to a y of 3. Okay, excellent. Now, you may be perfectly fine with graphing these expressions for those y's. I'm not. I don't have an easy time with it. So I'll show you what. Here's what I do, right? Here is, I'm going to put in, here's my y. I'm going to go from 0, 1, 2, and 3. And I make another chart. And I'll erase these after y. 0, 1, 2, and 3. And I'm going to get my x's, and then I'm going to graph. So let's start with the top function right here, right? So when I put in a 0 for the y here and here, I get a 0 for the x. When I put in a 1 here, I get 1 times 1. When I put in a 2 here, I get a 0 out. When I put in a 3, I get 3 times negative 1 is negative 3. Let me make sure I did that right again. When I put in a 3, I sure did. Now for this function here, when I put in a 0, I get a 0 out. When I put in a 1, I get a negative 1, negative 2, negative 3. And take a look. I must be right, I think, right? Because they really do intersect at these points. So what I'm going to do is, now I'm really good at graphing these XY points. Okay, so over here, here's 0, 0, 1, 1, 0, 0, 2, and negative 3, 3. Negative 3, 3. There we go. So goes like this. For negative y, that would be 0, 0, negative 1, 1, negative 2, 2, negative 3, 3. There we go. And here's the region. So here's my upper, is this parabola. Here's my lower, right minus left. So now I can set up my integral, right? I'm going to set that up from 0 to 3, and I'm going to do the upper function minus the lower. Okay, so I'm going to erase right here. And here's my integration. It goes from 0 to 3. Right-hand function, if you don't mind, I'm going to write that again as 2y minus y squared. 2y minus y squared, right? Nice little terms, easy to work with. And I'm going to subtract a negative y. And it's going to become positive. So, there we go. Just clean it up a little bit. Just going to come on over here. 0 to 3, all I'm doing is doing minus negative y squared plus 3y. Going to integrate now. So that would be negative y cubed over 3 plus 3y squared over 2 from 0 to 3. Right, so add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. There we go. And let's f of b. Let's see, that's that's 27 over 3, negative 9. Right, and then when I put a 3 in here, that's 27 halves. Minus. Now, luckily, when I do f of a, I do get a 0 out. So it would appear I have, see my negative 9 right here? Let's write that as negative 18 halves plus 27 halves equals 9 halves. And there's the area. Of course, it's positive, it has to be, but we did right minus left. Okay, on number 30, a little tougher as far as algebra goes. I'm really gonna need some room. You are assigned number 30. I'm going to help you set it up. There's only so many problems of these type in the book, so I kind of had to do the best with what I had. And I'll just erase the whole thing. We won't need tons of room, but saves confusion. So this one's a little different. It is in terms of x, right? And they want you to find the area between the cube root of x minus 1. Now, I, as a math teacher, know what that looks like because I'm a math teacher, right? It goes like this. It's the inverse, and it's been moved right 1, so it's going to come on through here. And the x minus 1 line. Okay, first of all, I have no idea where they intersect. So I'm going to set them equal to each other. Well, this is kind of a pain in the butt, right? So I can actually find a few places by trial and error, but I don't want to miss anything. So I'm gonna cube both sides. And I get x minus 1 equals. And I'm actually going to cube this out. So in your homework, you can, on number 30, you can start from where the video ends, just so you know. Okay. So x minus 1, I'm first going to multiply x minus 1 times x minus 1. And then I'm going to multiply that by x minus 1. So I've cubed it. So multiplying by x will raise each one of these exponents by 1. Multiplying by a negative 1 will change the sign of each of them. Whew. Okay, that's a mess. Let's take a look here. I think I want to get everything to one side, right, and factor it. Now, first of all, this x right here cancels out this x right here. Okay, this minus 1 cancels out this minus 1. And I get 0 equals x cubed minus 3x squared plus 2x. Just trying to find the x's where they intersect, right? Woo, trying to make a graph here. Greatest common factor of x squared minus 3x plus 2. And I can factor two numbers that multiply to a positive 2 and add to a negative 3. There we go. So now you can see why we're doing this, right? There are actually 3 intersection points going on here. That's a lot. Okay, now let's graph the line first, right? So 0, 1, and 2. So when I put a 0 in, I get a -1 out. When I put a 1 in, I get a 0 out, of course, because I know how to graph this line. When I put in 2, I get a 1 out, right? So obviously, so here's the line. Okay, now here's the hard thing. Notice then, if I put in a 0, 1, and 2 for x cubed, of course I'm going to get the same thing. That's why I said they intersect, right? If you put in a 0, you get a -1 out, right? If you put in a 1, you get a 0 out. If you put in 2, you get a 1 out. And you're like, well, how's it different? Well, how's it different is you kind of have to know what's going on in between. Okay, so what I'm going to do is, for my function, the cube root of x minus 1 right here, I am going to put in, let's see what's going on at 1/2. Right? Let's actually get that. And let's see what's going on. So that is, sorry about that. I had to get something off my calculator. Okay, so that would be the cube root. So that would be a -0.5, right? And it's cubed. Okay, so that's a -1.25. Okay, for the cube root function. Now at 1/2 on the line, I'm at a -1/2, right? So I'm just trying to compare here. So when I put a 1/2 in here, I'm at a -1/2. This one I am at, whoops, move my decimal, a -0.125. Right, so the -1/2, the -0.125 is above. So the graph is going like this, right? Now let's put in 1/2. When I put in 1/2, okay,